update everything so that our results are, when it comes to, when you finish your exams, I'll just mark it and update it for you. Okay, so that's on now. Yeah. Okay, so topic 8. And topic 8 is all about it's sequence and series part 2, but it's all about binomial expansion, right? So binomial expansion. And today we're going to be looking at Pascal's triangle. I have. Okay. Okay, so if I asked you to do, for instance, if I asked you to do x plus 1 squared, what would you have? What's your answer going to be? What's your answer going to be for that problem?
X to the power 2 plus 2.
So that would be x plus 1 times x plus 1, yeah?
Yes.
Which is equal to what? X squared yeah, plus x plus x plus 1, yeah? That's equal to what? X squared. Let me put that here. X squared plus 2x plus 1, yeah? Well, the first one is x to the power of 1, or x plus 1 to the power of 1. That's just equal to x plus 1, yeah? X plus 1. Let's put that there. We're going somewhere with this, okay? Let's just put that one there. Well, let me call it 1x plus 1. And this one is 1x squared plus 2x plus 1, yeah? How about x? Oh, I want to change that to something else. X plus 1 to the power of 3. Could anybody work that one out? Guys, work out that one quickly. Okay. Anybody did it?
X to the power 3
Yeah.
plus 3x plus 1.
Yeah. 1x to the power of 3. Gosh, the weather is so bad, man. Plus 3x what?
Plus 1.
Ooh, let's do that. Let's see. So this 2 would give you x squared plus 2x plus 1, yeah? And if we times that by x plus 1, or if we times x plus 1 by that, and then that would be x cubed plus 2x squared plus x plus x squared plus 2x plus 1, yeah? So what do you have here? X cubed plus what? 3x squared plus 3x plus 1. Yeah? That's right. So you guys, you can't even do expansion. Oh my goodness. Guys. Guys, come on. You're letting me down here. Okay, so well done. So this would be this one here. I'm going to choose green. This would be equal to 1x cubed plus 3x squared plus 3x plus 1. Okay, I'm going to put 1 on the top here, 3x to the power of 1. And I'm going to put 1 on the top here. Yeah. Maybe I'll put 1 there. I don't know. I'll leave it. Yeah. And if I asked you to expand x to the power of 4, would you be able to do that? Oh my goodness. That's just going to push the buttons a little bit further. Can anybody try that? You already know what x cubed is, so just multiply that by x times 1 and see whether you can get the answer. Okay, guys. Yeah. So this would be equal to x plus 1 times x plus 1 times x plus 1 times x plus 1. Let's see. Did anybody get it? Hi, Ali. Did any of you get it? So you already know that this one is x to the power. So you can just do x plus 1 times x cubed plus 3x squared plus 3x plus 1. Yeah? So what you will have then is x to the power of 4. This times this would be x to the power of 4 plus 3x to the power of 3. Yeah, this one times this one.
Plus 3x to the power 2.
Well done. Plus 3x to the power of 2. Yes.
Plus x.
Plus 3x to the power of 2 plus x. Yes. Well done. Plus 1x. Now plus, now times 1. We'll just repeat that part. X cubed plus 3x squared plus 3x plus 1. Yeah. So if we collect like terms, we have x to the power of 4, and we collect the x cubed terms, we have plus 3 or 4x to the power of 3 plus how many? 6x to the power of 2 plus 4x plus 1. Yeah. So here, what we'll have is 1x to the power of 4 plus 4x to the power of 3 plus 6x squared plus 4x plus 1. Anybody spotted any patterns yet in the answers that we are getting? Does anybody spot any patterns in our answers? Can anybody, can you see anything that is looking the same in your answers? Think about it and I'll be right back, okay? Have a thought. Let me get my cup of tea. Yeah. Anybody spotted anything there?
The 1 plus 1.
1 plus 1 is what? Where?
In the end of every answer, you have plus 1.
Plus 1. Oh, okay. Yes, yes. You got ones at the ends. Good. I like that thought. I like that thought. Yes, yes, yes. So you have ones at the ends. Ones at the ends. I like that thought. Okay. Any other thoughts? Any other thoughts? Any other thing that you spotted? Come on, guys. You should be able to spot something there. Trying my tea and honey. Be able to spot something there.
The first x is the same power of the question. For example, x to the power 2 is the same x plus 1.
Good, good, good. I like that thought. So you're having the powers is increasing by 1 each time. Yeah, I like that thought. So x to the power of 1. Yes, increasing power. So this is 2 to the power of 2 to the power of 3 to the power of 4 and to the power of 1. Well, what's happening in the middle numbers? So nobody's spotting anything with the middle numbers. Have a look at the middle numbers. What's happening with the numbers in the middle? Or have a think about the relationship between these two numbers and the one in the bottom, yeah? Or these two numbers and the one in the bottom. Or I'm going to give them different colors so that you can, these two numbers and the one in the bottom, yeah? So those two and those two and these two. What's happening with them? Let me write them out here. I'll write them out here for you guys so that you see them. I'll write the pattern out so that you see them, okay? You got 1 and 1. Then you got 1, 2, and 1 at the end. Then you got 1, 3, 3, and 1. Those who are missing this lesson, they are missing the fun of mathematics. Seriously, they are missing out the fun. 1, 4, 6, 4, and 1 at the end. Yeah, any patterns? Of course, you have 1 at the top here. Yeah. Okay, Khaled, that's fine. I'll look for you now on the register. You have to catch up now because we are trying to spot patterns. Okay. Nobody spot anything. Right. What's the relationship between this and this? What's the relationship between this and this, this and this? What's the relationship between this and this and this, this and this?
The first one, we add 1 plus 1, we got 2, then 2 plus 1, we got 3, 3 plus 1, we got 4.
Now I'm dancing. Yes, well done. Well done. Yeah. So you spot the pattern. Well done to you. at last, okay? So you can see the pattern there. I have that pattern. That's called the Pascal's Triangle. This is a triangle. It's called Pascal's Triangle. So I want you to write that down now, okay? And it helps us, it's very helpful when we are expanding brackets, yeah? Because you can expand x plus 1 squared, but even you realize when you got to x plus 1 to the power of 4, you couldn't do it anymore because it's getting more tedious. It's getting more tedious to keep on expanding these things. You can do x plus 1 squared, definitely. You can manage with x plus 1 to the power of 3. X plus 1 to the power of 4, just in the only 1 or 2 persons would try it. But when you come to x to the power of 5, x plus 1 to the power of 5 to the power of 6 to the power of 7, you can't, no, nobody would do it. But we use this pattern to help us, to find the expansions without really going through this process of expanding all of the brackets. Yeah, does that make sense? So now we know the pattern. Okay, we know the pattern. Okay, so those at the end of the rows are ones, and the others are a sum of the nearest two numbers in the row above them. Yeah, so at the end of the rows you have the ones, and all of the ones inside when you add the numbers above them, you get the ones inside. Okay, so that's how we work with Pascal's triangle. So let's go to my maths. Let's go to my maths now that I've given you a preview or a little idea of what we're going to be doing on my maths today. You share. So everything that I just explained to you is here on my maths. Yeah, x to the power of 1 is this, x to the power of 2, 3, and 4. Yeah, those are the expansions, and you could spot the pattern there: 3, 3, 1, 1, 3, 3, 1, 1, 4, 3, 4, 1. This could take a long time and it's easy to make mistakes. Is there a quicker way to do this? Let's look at the coefficients, okay? And you know what coefficient means? Do you know what coefficient means? Coefficient is the number in front of x, okay? The number in front of x. The coefficient of x is the number in front of x, okay? Right. So that's the triangle. The next line is found by adding the numbers above, okay? So of course, you know what the next line is going to be. So write another line of your Pascal's triangle. Write this other line of your Pascal's triangle for me. Okay, so you know what x to the power of 5, x plus 1 to the power of 5 is going to be. Yeah, you know what x plus 1 to the power of 5 is going to be just by including that line in the Pascal's triangle. Yeah, so guys, what is x plus 1 to the power of 6 going to be? Write x plus 1 to the power of 5 out. Yeah, and then let me know what x plus 1 to the power of 6 is going to be.
Can I say it?
Go ahead.
It's going to be 1x power 6.
Yeah.
Plus 6 power 5.
Yeah.
6x power 5 plus 20. No, 20.
Yes, you're right. Go ahead. Be confident.
20. 20 power 4
Good. And
plus 6. 6x plus 1.
so you would have 1 here. Then you would have this 2 will give you 6. This 2 will give you 20. This 2 will give you 20. And this will give you 6. And this will give you what? 1. Oh gosh. Have I messed it up now? I think you're right. This would give you 6.
Then 20.
How many 20s are there?
3.
Yeah.
No, just 3.
It's 3. Yeah. It's 3 20s in the middle. Okay. Right. Excuse me, did we just say 20? 5 plus 10 is 20. That's what I was wondering. Now you got me messed up by saying 20 for the first one. Yeah, that should have been 15. I was wondering, how many 20s are there? Oh, that doesn't seem right. So yeah, so well done to you, okay, Abdullah. Right. So it's 1x to the power of 6, 6x to the power of 5, 15x to the power of 4, 20x to the power plus 20x to the power of 3 plus 15x squared plus 6x plus 1. Yeah? So now you know. So write that out correctly in your books. And you see the powers are reducing, yeah? You see the powers are going down in ones. And at the end there, you have x to the power of 0, which is always 1. So that's why that's always 1 at the end, yeah? That's another reason why it's always 1 at the end. Okay, so yeah, so this triangle of numbers is called Pascal's Triangle after the mathematician Blaise Pascal, 1623 to 1662. Yeah, we reference him for his great job. Right. So how would you expand this one? A plus B to the power of 4. Now that we know how to do the expansion. Okay, so let's see how we do it. We use Pascal's triangle to help us. Yeah, we know that it's x to the power of 4, so we are going to be dealing with the 4th row here. Yeah, we're going to be dealing with the 4th row in the Pascal's triangle because it's x to the power of 4. Yeah, so then once we've done that, we can start the expansion. We have 1a to the power of 4 plus 4a cubed to the power of 3, 4a cubed, yeah? But we have b as well, so we have a look at how b is going to come in, yeah? So we've expanded all the a terms. Now we're going to bring in the b term, yeah? Now b is going up, it's not going down, yeah? It's not going down, it's going up each time. So here, this is what you will have. A to the power of 4 plus 4a to the power of 3 times b plus 6a squared b squared plus 4ab cubed plus b to the power of 4. Yeah, and that's how they expanded it. Okay, start with the expansion of the first one. Yeah, to the power of 4, 3, 2, 1. Yeah, then you come back with the other one. 3, 2, 1. Okay, you got it. Right. Write the expansion. I want to make sure that you understand how to do it before we even go into any practice questions. Mm-hmm. Okay, so I told you the powers of A are going to be going down from the power of 4, but the powers of B are going to be going up from the power of 0. So B to the power of 0 is 1, B to the power of 1, B to the power of 2, B to the power of 3, and B to the power of 4. I don't want us to do that one first. Let's do the simple ones. Okay, now you know. Now you know. Let's try the first one, okay? We'll try out this one. So you guys, you're trying it at the same time as I'm trying it. So have a go at the first one. We're all trying it together. Plus x cubed Okay, anybody got the answer for question 1? Anybody want to try? I'm going to check it first. This is topic 8. We're on topic 8, okay? Now, how do I put square in? I didn't see. Oh, yeah, I got it. How do I put cube in? All right, okay. Let's try it. Yay! So I got it. So guys, have you got it? Would you like me to explain how I got the answer? Or you want some more time to have a look at it?
Yes, teacher, we want to explain.
You want me to explain it? Okay.
Yes.
So I'm going to write that one down. Let me write it down. Then I'm going to come back to my 1 plus x cubed. Yeah. So here. Oh gosh, my board is looking so clear. All drawings. So I know it's one. Like, let me get a nice color. Let's get that color and make it thicker. I know it's 1 plus x cubed, yeah? So I know I'm going to be using the third line of the Pascal's triangle, the third row. Because it's x cubed, yeah? So I know that the first term here is going to be going up, yeah? Or it's going to be going down, right? It's going to be going down and it's going to have those coefficients. So it's going to be 1 x to the power of 1 to the power of 3 plus 3 times 1 to the power of 2, yeah, plus 3 times 1 to the power of 1, yeah, which is 3, plus 1 to the power of 0, which is 1, yeah. So this is 3, 2, 1, and 0. Okay, let me put everything in so that nothing confuses you. I'll put everything in so that it doesn't confuse you. 1 to the power of 1, 1 to the power of 3, 1 to the power of 2, 1 to the power of 1, 1 to the power of 0. And the coefficients is 1, 3, 3, 1. Okay. Now, going back, yeah, I'm dealing with x now, okay, and that's going to be going up. But I can start it from the back, I can start it from the front, yeah. I know that this can be x to the power of 0 and x to the power of 1 and x to the power of 2 and x to the power of 3. Yeah, so I've dealt with the ones and I've dealt with the x's. Yeah, so this would be 1x to the power 1x to the 1 to the power of 3 times x to the power of 0 is 1. Okay, 1 times 1 is 1 plus 3 times 1 square is 3. 3x, yeah, because x to the power of 1 is x, plus 3 times x squared is 3x squared, plus 1 to the power of 0 is 1, so that's 1 times x cubed, and that will be x cubed. Okay, so that's how I got my answer. Okay, guys, I don't want to make things complicated for you. Yeah, I don't want to make anything complicated for you or complex. I want you to try this out on your own now. With do x plus 1 cube for me. Expand it. Expand it for me. Let me see what you get. Some of you will be quick to do this. Some of you will be thinking, oh, where am I? You are still going to use this line. Things may still be the same. It's just maybe another way around. Okay, so try it out. Well done. Okay, so Abdullah, you got it, yeah? Right. Let me see. So let's go back to my maths and see what they have there. Maybe we can try out another question. So maybe we could try out this line, but it is minus. I think maybe what we need to do is try out plus first before we jump to minus. So guys, try out plus, okay? 1 plus x to the power of 4. Let's try that one out. Then we can see whether we can use that to try out 1 minus x. So you know this time you're going to be using the fourth line, okay? So you should have 1, 4, 6, 4, 1. Yeah. Okay. I got my answer. Mhm. Yeah. See for the math students, they cannot do maths anymore. Oh my goodness. You guys. Okay, so let's go to my whiteboard then. So for this one, x plus 1 plus x to the power of 4 to the power of 4. We know that we're going to be using the fourth line. We know that we're going to be using the fourth line. So, and the fourth line would be 1, 4, 6, 4, 1. Yeah. So we're going to have then 1 times 1 to the power of 4 plus 4 times 1 to the power of 3 plus 6 times 1 to the power of 2 plus 4 times 1 to the power of 1 plus 1 times 1 to the power of 0. Yeah? Then we have the x term going up. Yeah? So it's going to be x to the power of 0 plus x to the power of 1 here, x to the power of 2, x to the power of 3, and x to the power of 4. So on here, you would have 1. Everything will come to 1 because it's 1 to the power of 4 is 1 times 1 is 1. X to the power of 0 is 1. So it's all going to come to 1. Plus, everything else here will be 1. So it will be 4 times x, so 4x plus all of that will come to 1. So that will be 6x squared plus all of that will come to 1. So that would be 4x cubed plus x to the power of 4, which is what we have on our Pascal's triangle. 1, 4, 6, 4, 1. Yeah, we don't write that one down, but it's there. Okay, guys. I don't know why you guys are scared of this. I feel your energy from here. Okay, finish writing everything down. And then we go back to my maths. I'm just gonna have a look at this one now, yeah? Let's have a look at this example. So for this example, we had 3x minus 2, yeah, to the power of 5, yeah? We need the fifth line of the Pascal's triangle, yeah, which is 1, 5, 10, 10, 5, 1. So I'm just going to try that out now because that's plenty. So let me try it out. Yeah, then I'll explain it to you. Okay, guys. So we're using the fifth line, 3x minus 2 to the power of 5. So that is 1, 5, 10, 10, 5, 1. Okay, so then you would have 3x to the power of 1, 5x to the power of 2, 10x to the power of 3. I done that wrong. So this should be 5 here. 5. And this should be 4 and 3. And 5x to the power of 2 here. And 5, 4, 3, 2. Oh, 10, 10. Yeah. And then 5x to the power of 1. And then 1x to the power of 0. And then we'll have the other one going up. So here it will be negative 2 to the power of, let me see. Yep, so we have negative 2 to the power of 1, negative 2 to the power of 2, negative 2 to the power of 3, negative 2 to the power of 4, negative 2 to the power of 5, and negative 2 to the power of 6. Ooh. Shouldn't have 6. No, I started from 1. 0, 1, 2, 3, 4, 5. Yep, 5. So yeah, I'm happy with that bit. I will explain it to you guys now. Right. Three times x to the power, 3 times x to the power of 5 plus negative 2 to the power of 0 is 1. Yep. Yep, I get that. Yeah, so that's the fiddly bit. You have to do it. So let's do it together. Let's do it together on, I'm going to take a picture of the answer. And we can do it together on my whiteboard. So you guys just follow the process, okay? Follow the process. I'll find a nice one for you for your exams. Right. You share. Whiteboard, share. So we had to do 3x minus 2 to the power of 5. Yeah. So we know that we're using the fifth line of the Pascal's triangle, which is 1 2 1 1 3 3 1 1 4 6 4 1 1 2 3 4, and the fifth line would be 1 5 10 10 5 1. Okay. So we're starting with the 3x, the first term. We're going to expand that one to 3x to the power of 5. It's going, yep, so 1 times 3x to the power of 5. Yeah. We're going to put plus 5 times 3x to the power of 4 plus 10 times 3x to the power of 3 plus 10 times 3x to the power of 2 plus 5 times 3x to the power of 1. I should have been putting that there. Plus 1 times 3x to the power of 0. Yeah, so we get that bit. Now we're going to times that by the other part, which is going to be going down. Negative 2 to the power of, it's going to be going up rather 5. Zero, and negative 2 to the power of 1, and negative 2 to the power of 2, and negative 2 to the power of 3, and negative 2 to the power of 4, and negative 2 to the power of 5. Yeah. Okay, so now we need to write this in it. We need to do all the mathematical jiggery-pokery that is left now. Okay, we need to do all the maths that is left here to finish this off. Any suggestions how we would do this? Any suggestions?
Miss,
Yeah.
to be honest, I did not understand.
Oh, what don't you understand? You don't understand the binomial expansion, or what don't you understand?
Yeah, the whole thing. I just understood the first thing when it was x plus 2. That's all.
Well, you're not going to keep on drinking milk, are you? You're going to eat bone at some point, yeah?
Yeah, but I didn't understand.
So this is just a bit more challenging than the first one. The first one, you found that one easy because it was x minus 1 or x plus 1. Yeah. So this one's going to be a little bit more challenging than the first one. Okay, let's go back and start from the beginning. Maybe you will understand it then. Okay. Okay. Right. I told you about x plus 1, x plus 1 squared to the power of 3 to the power of 4. You understand that part, don't you?
Yes.
Good. And we worked out the Pascal's triangle because we said we use them for the expansion. Yeah, the first row, the second row, the third row, and the fourth row, we use them to do expansions. But these expansions that you did here were for plus 1. Okay, plus 1 does not give much problems because you only have the x term, and the other term is a number term, which is like 1. It's not really, it doesn't make much difference. But now we're introducing other terms that are much more than 1. So you will see differences. Yeah. So you got the Pascal's triangle. You can do it. You know what it is. And you can use it. Okay. Now we tried out this one to expand a plus b to the power of 4. Did you understand how we did it with this one?
Kinda. Yeah.
What's kind of? Like, you start with the first term. Yeah? 1 times a to the power of, it's going down, isn't it? 4 plus 4 times a to the power of 3 plus 6 times a to the power of 2 plus 4 times a to the power of 1 plus 1 times a to the power of 0. Do you understand that part?
Yes.
Now you have to do it for the B term. Okay, for the B term, it's going, let's start from here. It's going the other way, backward, down, yeah? So it's b to the power of 4 times b to the power of 3 times b to the power of 2 times b to the power of 1 times b to the power of 0. Do you understand it now? So now,
Yes.
this is going to be a to the power of 4. Yeah, start. Plus 4a cubed b to the power of 1 plus 6a squared b squared plus 4a b to the power of 3 plus a to the power of 1 is 1 plus b to the power of 4. Okay, that's the expansion of that one based on the Pascal's triangle. Is that okay with you?
Yes.
I don't want to push it. So let's do another. Do for me x plus y to the power of 3.
Miss, I think I solved it.
Ah, so now you understand. Okay, so
I still want to check my answer.
yeah, that's fine. At least you're trying to do it. That's the main thing. Yeah. So what did you get?
I got one x power 3.
X to the power what?
1x power 3
Yes.
plus y power 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 1 power 0.
Yes.
Then,
X to the power of.
then I got 3x power 2 y power 1.
3x to the power 2, y to the power 1. Good. Excellent. You see, you're doing good. It's all about trying.
Then I got 3x power 1
Mm-hmm.
plus 1.
Mm. Y
Plus
to the
x,
power
sorry.
2.
Yeah, plus x.
Have you finished?
Yes.
Yeah. So you should get x to the power of 3 plus 3x squared y plus 3x y squared plus y cubed. Okay?
Okay, I made a mistake in the last one.
The way I've done it so many times that I can do any of the patterns. Let me not give you guys anything harder than this for now. I think you guys just need the basic practice of these ones. So that's what I'm going to be doing with you now. I'm just going to let you practice these ones. I'll change the letters and change the powers and see whether you can get them. Have a go at this one. We got how many minutes break time? Question B. Y plus Z to the power of 4. Have a go at that one. Have a go. And that's everybody, please, because I've kind of just reduced the whole lesson to the point where you guys can cope. Okay. You guys, you can go for your break, and after the break, we can continue, all right? Back at 10:45, I think. Yeah. Hmm. Welcome back, guys. Right.
Hi, miss.
How are you?
Good.
Okay. Let's do the register, okay? Hmm. Come on. For the maths. 10:45. Scheduled. Abdullah allowed. Abdullah. Naji.
Yes.
Abdurrahman. Alanazi.
I'm here.
Ariam.
Yes, I'm here.
Hamad.
Yes.
Reem. Ibrahim. Khaled. Alotaibi.
Yes, I'm here.
Ali. Abdurrahman. Ashamri. Uday. Yeah, but you need to answer to your name because I'm not on, I'm on a different platform when I'm marking the register. So if you don't answer your name, I can't be going back to Zoom to read the message that you're sending to me. Okay, Khaled Bauchi.
Present.
Yep. So if I call your name on the register, you have to answer because I'm not on Zoom when I'm marking the register. I'm on a different platform. I cannot be going back to read the message that you sent to me on Zoom to come back to mark you on the register. That's double work for me. So it's just open your mouth and say present or yes, I'm here or anything, and I'll know you're there. Okay, right. Okay, so I hope everybody had a good rest and you're back now. Your brain is now switched on. I don't know what you all are trying to study in university, but you have to step up your game. You have to be resilient when you're doing maths, okay? And you don't have to be like if you get onto a topic that you find a little bit challenging, especially if you're doing it for the first time, you have to be, give yourself a little bit of credit or take it easy on yourself, if I may put it that way, because you're just doing that thing for the first time. And it's like when you learned 1 + 1 in primary school, it's not going to be the same as when you're doing it now. 1 + 1 now is a waste of your time because why will anybody want to teach you that? Yeah. So that's how it is. It's like learning ABC again, learning something new, a new concept. So it takes a while for you to grasp that knowledge or that thing. And you have to understand yourself as a learner. What type of learner are you? Are you the type of learner that grasps something quickly? Or do you need a bit more? Some people, as soon as you explain something to them, they got it the first time or the second time. Some people need a little bit more practice on something to do. So if you're that type of person that needs a bit more practice, then you have to dedicate your time to practicing so that you get it right. Yeah. You have to understand yourself as a learner to be able to succeed. Yeah. Good morning. How are you, Rim? Okay, I'll mark you in now, right? So it's a new concept, and if you just sit there looking at it and thinking, oh, this thing is so difficult, I can't do it, you will not be able to do it. The only way that you can do it is if you try it out. You get it wrong, you sit back, then you go back and try it out again. You get it wrong again, you sit back, oh, what kind of thing is this? You try it out again. I bet you by the third attempt, you would have gotten it right, okay? So you need to understand yourself as a learner, and the subject that you're learning, maths, is not a lying down subject. It's a doing subject. You have to do it. If you don't do it, you will not know it. Yeah? Okay, guys. Too much talking. Let's get on. I think I saw Hamad's answer in the chat. So well done to you, Hamad. I'm going to have a look at what you wrote. And what was the question? Y plus Z to the power of 4. Is it Y plus Z to the power of 4? Yeah. And you said your answer is Y to the power of 4 plus 4Y to the power of 3Z plus 6Y to the power of 2Z to the power of 2 plus 4Y to the power of 3. Plus 4Y and Z to the power of 3 plus Z to the power of 4. I think that's pretty much straightforward. That's what we had in the question anyways. Yeah, that's what we had in the other one, the A plus B to the power of 4. So well done to you. Yeah. Okay, let's go back to my maths where we are trying to learn this topic and see whether we can do at least one more. Yeah, at least one more question, then I'll let you guys off, and then we can look at our Moodle and see where we are with things and see if we need to spend this afternoon or the rest of the lesson to mark stuff and get stuff done on there. Stop share. It's giving me stress now. I'm already logged in. Why are you logging me out? Okay. So this was the one we did. We did this one first. I did this one first and I showed you. I think they changed it a little bit. Yeah. They've turned it around. Let's go back to the example. Yeah. So for this one, they used the fifth term. They used the fifth line of the Pascal's triangle, the fifth row of the Pascal's triangle. Okay. So you know that this first number is going down, starting from the power of 5, and the second term is going up, starting from the power of 0. Yeah. This one will go down, starting from the power of 5 all the way down to 0. And this one will go up, starting from the power of 0 all the way up to 5. So that's what's happening here. Okay, so these are the numbers in the Pascal's triangle. Yeah, in the fifth row of the Pascal's triangle, times 3x to the power of 5 Who is this that just came in? Abdullah, who? Hang on a minute. Have I marked you or not?
I don't think.
Oh, are you just coming in?
Yes.
Okay. Okay. Yeah, so it's the same thing that we've been doing. It's the same thing that we've been doing. So let's do this one now, yeah? 3x minus 2 to the power of 5. New share, whiteboard, share. So we had 3x minus 2 to the power of 5. And we were using the fifth row of the Pascal's triangle, which is, I think this is the first one, 2, 1, 3, 3, 1, 4, 6, 4, 1, 5, 10, 10, 5, 1. So it's that one that we're using, yeah? So we're going to start off with this one, yeah? And that one is decreasing, so 3x to the power of 1, add 5 times 3x to the power of 2, plus 10 times, I'm sorry guys, this is x to the power of 5, and this is 4. 10 times 3x to the power of, it's very fiddly, that's why you see me going back and forth on it, plus 10 times 3x to the power of 2, plus 5 times 3x to the power of 1, plus 1 times 3x to the power of 0. Yeah, and then this other one is going down. It's going down in starting from 0. What is this now? Oh. So this would be, let me use a different color pen so that you see it. Negative 2 to the power of 0 times negative 2 to the power of 1 times negative 2 to the power of 2, negative 2 to the power of 3, negative 2 to the power of 4, and negative 2 to the power of 5. Yeah? And this was where we got sort of confused. Hey, what do we do next? Oh my goodness. So if you have, let me have a look now. 3 to the power of, oh gosh, come on. Yeah, so I already taught you before that if you have 3x to the power of 5, that means you have to apply that to both of them, yeah? So that will be 3 to the power of 5 times x to the power of 5, which is 243 for 3 to the power of 5. So 243. Let me expand this so that you guys will not go crazy. 3 to the power of 5, x to the power of 5, yeah? So that's going to give you 243 x to the power of 5, because 3 to the power of 5 is 243, and any number raised to the power of 0 is 1, so that's the power of 1, okay? Plus 5 times 3, what's 3 to the power of 4? 81, yeah? X to the power of 4, yeah? Times negative 2. I'm just going to leave that there. Plus 10 times 3x to the power of 3. What's x to the power? What is 3 to the power of 3? It's 27. X to the power of 3 times negative 2 squared is what? 4 times 4. Yeah, plus 10 times 3 squared is 9. X squared times negative 2 to the power of 3 is negative 8. Plus 5 times, do you see how cumbersome it is today? Yeah, tomorrow when I teach you using NCR, it's going to be a lot easier, okay? Right, so then 5 times 3x, I think 2 to the power of 4, is that 16? Oh, negative 2 to the power of 4. It's 16, yeah? Times 16 plus 3 to the power of 0 is 1. Negative 2 to the power of 5 is negative 32, I believe. Yeah. Okay, so then you can simplify this further. I'm just writing it all out so that you see how the numbers are coming. If you follow along with me, you won't get so messed up. You won't get so confused. So just follow along with me. And if you get confused, give me a shout out. Plus 5 times 81 is what? 405 times negative 2 is negative 801. So 810. So we have to change this one to negative 810. Yeah, x to the power of 4. Do you know how I got that? Here is 5 times 81 times negative 2. Yeah, all of these ones times them together. Right, plus 10 times 27 is 270 times 4. 1080 x to the power of 3. I think this one will be negative now because we have negative 8. 10 times 9 times negative 8. Negative, negative 720 plus 5 times 3 and 16 is 240x minus 32. Okay, so that's our expansion. Yeah, that's our expansion of that number using Pascal's triangle. All right, guys, now don't panic. It's not difficult. It's just to follow the steps. It's just to follow the steps. Yeah, just to follow the steps. Make sure that you write everything down that I've done on the board. Write it down, how I've done it, and follow the steps. If you don't follow it, let me just take a screenshot of that now so I don't forget how I explained it. That's hard as well. Okay, let's go to my maths and see if we can do at least one. Okay, if we can do at least one, then we are good. Now this is going to be an easier one because it's not, we did x to the power of 5, so this is x to the power of 3, so you can do this one. Come on, stop share screen, annotate. No wonder it wasn't letting me. Have a go at that one for me. Okay, see if you can expand it. Okay, you know that is x to the power of 3. You're going to be using the third line. Okay, and I'm going to put 1 in your assessment now for you. In your module assessment now for you. Assessment 8A. And you can do that now in class. Where's your module? Right. Oh, I just removed something important. I'm so sorry, guys. What have I just done? Can you guys still see the screen? Stop share. I removed everything. Let me put it back on. Oh my goodness. I think that was on the classic one. Oh my gosh. What's this? Oh, it's all back on now. Was it here? Okay, it was here. So they were all not working anyways because nobody could do it. And nobody noticed that I removed it. So this is the one you're meant to be working on, okay? 1 1 1 3 2 1 1 3 3 1. Yeah. So you should start off with 1 times 2x to the power of 3 plus 3 times 2x to the power of 2 plus 3 times 2x to the power of 1, 1, yeah, plus 1 times 2x to the power of 0. Then going backwards now, or starting the other for this other term, you would have 1 to the power of 0 plus 1 to the power of 1 plus 1 to the power times 1 to the power of 2 times 1 to the power of 3. This one is an easy one. I don't know why people can't do it. This one here. Because you would have ones in the end and all of them will come to 1. Okay, let's do that one together. 2x plus 1 to the power of 3. And x plus 2 to the power of 3 and 1 minus 3x to the power of 4. I think I'll put this one for you as your assessment. Stop here. Let's do it on my whiteboard. So you have 2x plus 1 to the power of 3. If you have the power of 3 there, you're going to be using the third line of the Pascal's Triangle. 1, okay? So then you start with the first term, yeah? And that will be raised to the power of 3. Times it by 1. 1 times 3. 1 times 2x raised to the power of 3 plus, now times it by 3. 3 times 2x raised to the power of 2. Now times it by 3 again. 3 times 2x raised to the power of 1. Now times it by 1. 1 times 2x raised to the power of 0. Now start to look at the second term, the other term there. Yeah, so this would be times 1 to the power of 0 times 1 to the power of 1 times 1 to the power of 2 and times 1 to the power of 3. Okay, so of course all of these ones will come to 1. They will all come to 1. So what you'll be left with would be 2x to the power of 3 plus 3x. Oh, now you need to do a little bit of expansion on this one. Yeah. This here would give you 3 times 4x squared, okay? Because you're applying that to the 2 terms in there. And the same thing on this one, 3 times 4x squared. And at the end, you would have 1 because this to the power of 0 would be 1 and 1 and 1. Okay, so here you have 12x squared plus 12x plus 1. That's so easy and straightforward, guys. Come on. Come on, guys. What's happening? Okay, your homework, okay? Your homework. One, it's not even homework, it's assessment. So let's go and put it on Moodle now. Because people will have to wake up from your slumber. Weybridge. Okay. Where's your topic 8? Oh, we have to do a lot of work today then. Turn editing on. Stop share. And who is messaging me? It's Friday. Oh, yeah, it's probably the reason. Okay, you guys don't worry, you'll soon finish, okay? Everybody's geared towards a different mode. Yeah, in a different mode. Okay. Right, let's see. I'm going to have to stop the live on YouTube because I finished teaching you the topic, okay? So we can do some work on Moodle before we finish, okay, guys? Copy streaming link first of all. I'll take it to Moodle and put it on topic 8. I'm just gonna duplicate this one, put it here. If you can do it now, you just do it now. I'm going to share the screen with you guys. Just do it now so you don't have to like be worried about doing it, closing or this and that. Let me stop the live stream since I've copied the link. Oh. Edit settings. Remove. Binomial. Pascals Triangle. Binomial Expansion. Pascals Triangle. This one is NCR. I'm just going to remove this one. I will do that in the next lesson. Save. Okay. My face looks funny, guy. Topic 8. Add topic. Add topic 8. Okay, add an assessment or an activity. Share screen. Share. Okay, I'm going to add something for you guys to do for me now, okay? Please. You don't have to do it. You can do it in the class now, so you don't have to worry about doing it later. Pascal's Triangle. Topic 8. No timing, no brain, no layout. Just give me the feedback. Now that's so confusing now because it's not letting me do anything. Okay, so let me just put some questions in there for you. Who is texting me? I can't even see my messages. Yeah, that's fine. No problem. I'm not going to close it, yeah? I'm not going to